Functions are one of those topics where the maths itself isn't that hard, but the notation really puts people off. In this video we're going to slow everything down and focus on what the symbols actually mean. By the end you'll understand function notation, composite functions and inverse functions without having to memorise tricks. Let's start with the most important question. What does f of x actually mean? Well, f of x does not mean f times x. A function is best thought of as a type of number machine. You put a number in, the function does something to it, and you get a number out. Here we have f of x equals 2x plus 3. X is the input and f of x is the output. We can assign any value to x and the function will give us some output. For example, when we put x equals 6 into the function, we get back 15. If we put x equals 0 into the function, we'd get back a value of 3. And finally, if we put x equals minus 2 into the function, we'd put minus 2 in for where the x is, and we'd get a value of minus 1. What does f of g of x mean? This is where a lot of students panic, but it's really just notation again. This does not mean f times g times x. Well, this is an example of a composite function, which basically just says we've got a function within a function. Let's see this in an example. Given that f of x equals x plus 1 and g of x equals 2x, work out the value of f of g of 3. We can start by trying to find an expression for the composite function f of g of x. So, like I said, this is just the function g of x placed within the function f of x. So we're going to take the function f of x and put g of x in where the x's were before. And as g of x is equal to 2x, we can put 2x into the f of x. And there we have it, our composite function f of g of x is equal to 2x plus 1. Remember, the question asked us to work out f of g of 3, so we can put 3 into our composite number machine and get 2 times 3 plus 1, or 7. An inverse function does the opposite to the original function, so if a function adds 3, the inverse subtracts 3. If a function multiplies by 2, the inverse divides by 2. Here's an example. F of x equals 2x plus 3. We've been asked to work out the inverse function. To find the inverse, we're going to follow the same steps every time. So our first step is to swap the f of x for a y. Now we're going to swap x and y around. Finally, we rearrange to make y the subject. So in this case, we're going to need to take the 3 over to the other side of the equation, making it a minus 3, and then finally dividing by 2. This is our inverse function. Just a reminder to be careful with your notation here. The little minus 1 does not mean to the power of minus 1 or 1 over f. It purely indicates that we have an inverse function. Let's remind ourselves of the 3 rules that we've just learned. We're going to start off by swapping out f of x for y. We're then going to swap y and x around and then finally make y the subject. Let's do a challenge question. This is going to be a tough question, so don't worry if you don't find it easy. The functions f and g are such that f of x equals 2x squared minus 1 and g of x equals 3 divided by x squared. The function h of x is such that h of x equals the inverse of f and g. Find h of x. So there's quite a lot to unpack here. We're going to start by finding the composite function f of g of x. So how are we going to do this? Well, if you remember, we take f of x and we're going to substitute g of x into it. Now we have an expression for our composite function, we can start to think about how we might find the inverse of it. We can remind ourselves of the 3-step method that we wrote down previously. So we can start by swapping out the function for y. We can then move on to the next step, which is to swap y and x around. And finally we can move on to the 3rd step, which is to make y the subject. Now the algebra is going to get pretty tricky here. So we'll start by moving that minus 1 over to the other side of the equation. We can then divide both sides by 2 and then square root. Now, on the right hand side we have the y squared on the denominator, so we're going to need to take the reciprocals of both sides. Basically, we're going to just flip both fractions. And then finally we can times both sides by 3, and then take the square root again. So finally, just to tidy up, I'm going to take that square root of 3 inside the 4th root, making it a 9. And there we have it, we've worked out the inverse of the composite function fg. From the question we know this is defined as the function h of x. Now that's about as hard as these questions are going to get. Let me know what you thought in the comments. Please like and subscribe, and I'll see you in the next video. Thank you, bye bye.